Welcome back to our second part of our test video for the right triangle trigonometry. Oh wait, no, about right triangle trigonometry. So before I begin, I would like to say something important that I think I mentioned previously that we're going to have a problem solving questions here. I think I said that. If that's the case, unfortunately, we're not going to do some problem solving here, but rather we're going to do it in the next video so that I can basically separate the what I call this one, the type of test. Because here in the second test, we're just going to have true or false. All right. So forgive me if I haven't updated you. If if I had mentioned that we're going to have problem solving questions here, when in reality, we're not going to do it in this video. All right? But don't worry, this video will just be short. It's shorter than the previous video. Right? So let's not make it longer and let's now proceed to this test video. Let's go. So true or false? Sine theta is the same as cosine theta. Yes or no? Right, let me just zoom in my camera. So is it a yes or no? So to answer that question, it is no. It is in fact false. Why is it false? All right. Well, it is not only because they're not the same in terms of how they look, but if you're going to put an input on each of the trigonometric function, there is a chance that they will have a different value or different answer. Now, if you're going to ask me if I said there's a chance that there will be some, let's just say, not the same answer from sine and cosine. So does that imply that there is a chance that they will be the same? Well, to answer that question, yes. Basically, sine theta is not always equal to cosine theta, but sometimes, yes, or in some cases, yes. Let me give an example. So, sine of 30 degrees, cosine of 30 degrees. What is sine of 30 degrees? We all know that sine of 30 degrees is 1/2 units. For cosine of 30 degrees, however, this is square root of 3 all over 2. So you can clearly see the difference between the two. So they are not the same. But if we input sine of 45 degrees instead of 30 degrees, then their answer would be the same because sine of 45 degrees and cosine of 45 degrees is equal to square root of 2 all over 2. Okay? So yes, in some cases, there's a chance that they would be the same, but not always. So therefore, the answer for this is false. Okay, this is false. Next. Wait, there you go. Sine theta is the same as cosine of 90 degrees minus theta. In this equation, this is in fact true. All right? So let me prove it to you. Let's just say that I have sine of 60 degrees. So substituting theta as our 60 degrees, I mean, say, substituting 60 degrees as our theta, we will have 90 degrees minus 60 degrees. So now what we're going to do is we're going to simplify the right side because we can combine them. So we will have cosine of 30 degrees. Now we get the value. What is sine of 60 degrees? So this is square root of 3 all over 2. And cosine of 30 degrees is also square root of 3 all over 2. So see, they are in fact uh, the same. Okay? Well, how about let's just say we try another one. Let's just say we have sine of 30 degrees. So we substitute it here. Cosine of 90 degrees minus 30 degrees. So on the right side, we will have cosine of 60 degrees. Now we will compare the two. So sine of 30 degrees is 1/2. And cosine of 60 degrees is also 1/2. Therefore, it is proven that sine of theta is just the same as cosine of 90 degrees minus theta. All right, you can try other different angles. Even if the angle is not a special angle, you can try it. All right, you can try to experiment it or experiment by yourself. Okay, so we're done with the second problem. So this is true. This is false. Next, tangent theta is equal to negative tangent theta. True or false? This is actually false. Well, logically speaking, you can clearly see the difference, right? The difference, like one is the positive sign and the other is negative. So, yeah, obviously, it doesn't make sense at all. You know, like we have two sides where one is tangent theta and the other is tangent theta, but it's negative. All right. But let's just say that, assumingly speaking, that let's just say there's a chance that there is an equation that they are the same. You know, like always, like there's a chance that there is a trigonometric equation where the positive and the negative are the same. All right. Let's just assume that. Still, it's still wrong. All right. I mean, still, it's wrong. Why is it wrong though? So here we can apply what we learned before, which is from even odd property. Okay. So suppose we have a negative input for our tangent function. If we have a negative input for a tangent function, we will have negative times tangent theta or negative tangent theta. So meaning our answer should be tangent of negative theta is equal to negative tangent theta. So this is in fact false. Okay, this is still in fact false. It should be tangent of negative theta, not positive theta. Okay, so next problem. Cotangent of negative theta is just the same as negative cotangent theta. Is this true or false? This is in fact true. Let's prove it, okay? So first and foremost, let's have a recall. Wait, let me just shorten my camera here. I'm gonna use the remaining space for solution. Let's prove it that cotangent of negative theta is just the same as negative cotangent theta. Okay, so remember that in the reciprocal identity for cotangent theta is just the same as the reciprocal of tangent theta. Basically, cotangent theta is just the same as 1 all over tangent theta. Okay? So, what happen if we put negative input for the cotangent theta? So that will be also the same for the input of our tangent theta. It's also negative. So cotangent of negative theta is equal to 1 all over tangent of negative theta. But here's the thing. We knew earlier that tangent of negative theta is just the same as negative tangent theta, right? So we can simply rewrite this as 1 all over negative tangent theta, right? And we can actually factor out the negative sign. Like we can put it beside the fraction, so we will have negative 1 all over tangent theta. Okay, so that's it. But again, remember that 1 all over tangent theta is just the same as cotangent theta. So therefore, we can simply rewrite this as negative cotangent theta. Hence, it is verified and proven by me that cotangent of negative theta is just the same as negative cotangent theta. Okay, so it is in fact true. So let me just erase my handwritings here. I think we will have last problem. Because that's already good enough, because let's not try to reach it like more than 30 minutes, okay, or more than 15 minutes. Anyway, so we have this one. Oh, wait, by the way, there's a correction here. This is cosine of theta plus 2 pi, all right? Forgive me. There's like a misinput here. I forgot to input cosine here. But anyway, let's proceed. According to the periodic property, tangent theta is equal to tangent of theta plus 2 pi. Sine theta is the same as sine of theta plus pi. And cosine theta is the same as cosine of theta plus 2 pi. If you're asking me, is at least one of them correct? Then the answer for that is yes. But if you're asking me, are they all correct? Like logically speaking, are they all correct? The answer here is no. So the answer here is false. Why is it that not all equation here is correct? Let's start first with tangent theta. The tangent theta one, it should not be theta plus 2 pi, rather it should be pi only. So this is wrong. Should be pi only. Okay? And lastly, for the sine of theta should be the same as what is for the cosine theta. So basically, sine theta should be sine of theta plus 2 pi. 2 pi, right? The same as for the cosines, which is like this, theta plus 2 pi. And since I already mentioned that uh, since I use an example of cosine, we can say that this is correct. Okay? So point being, tangent theta should be tangent of theta plus pi. Sine theta should be sine of theta plus 2 pi. And lastly, cosine of theta should be theta plus 2 pi, which is almost the same as sine, right? And I think that will be all. So here in test 3, we're going to have some problem solving, right? So I think here we're going to prepare some, what do you call this one? We're going to prepare some papers or and pen or pencils or whatsoever that you can use for writing. All right? So see you guys soon.